How's it going, everybody? Julian Gonzalez here, and in today's video, we're going to take out this hidden, mysterious, fuzzy term called generators in JavaScript. And that is something interesting because, especially when you hear topics like iterators and generators, it's like you don't have idea what is this mean. And something that now with the EX6 and EX7 ECMAScript specification. So now they provide you features as a way to deal with this async nature. That's one. And also how now you can build applications using the object-oriented programming, especially the way how JavaScript was built using the prototype, okay, as a way to have access to property and methods that allow you to now build programs at scale in a professionally engineering environment. Sorry. So on that, and I think that's something very, very important as a way to improve not only as a software engineer, but also as a person that you're going to provide this service to someone, to your clients, so you can help them to not only achieve their goal, but thrive their business. And in the meantime, work on this intellectual rewarding task while getting paid for that. And I think that's something, again, that might sound like a good deal, by the way. And the goal of this course, the hard part of asynchronous JavaScript, which is a course taught by Will Sentence. So shout out to Will Sentence, the CEO of Codesmith, this software engineering and machine learning residency headquarters in New York and California. Uh, so again, here we're going to see is that how these EX6 and EX7 features that now the designers of JavaScript brings to us as a way to know how JavaScript is the asynchronous nature of JavaScript actually works, how now have this way of thinking of how can we access to our data, and then how now we have this particular way of how can we control the data flow of our data. Use the first is through iterators, and the latter is through generators, and how you can combine this with the async and await as a way to now have a precise understanding of how now this async nature happens behind the scenes. So this course is now outlined in several sections. So we look at the introductions, and then the asynchronous nature. So now we look at the promise, and then subtle topic in between as a way to make our as a way to develop a sense of how can we now uh, learn and understand is the iterators and then generators and then how they combine each other with the async and await syntax. So another important thing, especially if you are in a senior developer, which is one of the reasons why a lot of people, especially if they are in a particular industry, they need to provide more value, and also they need to find a way to solve their own problems. Again, we are grow up people that we must take care responsibility of our own. Our parents are responsible for ourselves until 18, 21. Then it's up to us how to do that. And especially if you go out now to a particular company, and I don't have to say that uh, that company and you now make a contract so you can now work for them. An offer is your skill, your time, and your expertise in an exchange of their exposure, security, and their system. So now then you can use collaborate with them, and down the line you can also create perhaps your own company to actually find and solve their particular problem. Okay, in any way, uh, the role of a senior developer especially is to, unlike mid-level juniors, where they can giving so they can take a look at implementations on, or they can take a look at a feature and implement that even though that they haven't seen that solution or that problem before. But unlike with seniors, which they can do that as well, but also make it meaningful to others. And that's one of the key value of these senior people, any role you are, whether it's senior data analyst, senior JavaScript developers, Python, PHP, it's like how they can now make it meaningful to others, because at the end of the day, we make sense of the world through stories, storytelling. That's the reason also why I'm now recording this set of videos as a way to now create that narrative, and especially when I need to explain that to someone that is non-tech savvy or on college or business people, now I have a precise way to communicate with them so I can identify the requirements, how can I translate that, and then figuring out how can I implement a solution and then explain that. That's part of the first, some couple skills that companies and you must develop. First is the analytical skills. How good is your thinking process? How good is your how good are you describing is your solution? And the other is the technical communication, which is a combination with the analytical. Is that can I implement your approach based on your description, where by following is good practice in the language, or engineering good practice, which is the third topic, and by having patience with your colleagues and with yourself, uh, which is part of the soft skills. Now you can provide ultimately value to the company, and the specification in the language and that kind of thing is, even though that they are important, but also all the things that we have mentioned before. And that's exactly what a lot of these companies out there are looking for. So in any case, uh, the Codesmith, which is this particularly business, or where the Will Sensing is the CEO, is now want to grab all of these people that come from boot camps, which is a good thing, and kind of accelerating into a senior role, which to me that's great. Uh, because at the end of the day, the economy and business rely and require people that can provide value. It's quite hard to do that, but it's not impossible. And after all, it's a task that you should do that day by day. So finally, enough me, enough of this huge overview. Uh, so here is this. So first, the introduction is that we're gonna take a quick recap of all of these topics, okay? Because I mean all of these topics, because what we care about is the generators. Okay, so first an introduction of how is the uh, I mean the basic features of JavaScript. Okay, so we're gonna briefly mention that the thread of execution, the global execution context, the function execution context. Each one of those execution contexts contain is their own variable environment, global or function. Okay. Also, you have is the call stack as well as the closure. So these features is what makes the JavaScript engine provide all of these beautiful designs and interactivity in these programs uh, that we can now take a look take a look at the next step, which is how can we make JavaScript asynchronous, or how can we now defer tasks that will take some time or that will be completed somewhere in the future. So for that, we have now facade functions called set timeout, and those facade functions are exposed to the JavaScript world so they can talk to the outside world, in this particular case, to the browser or node. Okay. In the context of browser, you have is the DOM or canvas as a way to draw things here, or the audio. Hey, I would like you to now reproduce this different sounds or playlists. Okay. Also is uh, how elements can we now be drag and drop in the UI, the way of this. Uh, how can we now make async operations when it comes to talk to other servers, okay, like fetch functions, something that we're gonna see, as well as the um, timers. So this function that is exposed by the browser, the web API, okay, is now when we can pass a callback function. Very, very important here. We're passing is a reference. And by passing is a reference, we're not passing is this function that will be executed. No, we're passing is just a link to that set timeout. So followed by a milliseconds. And this is the way how you can communicate to the browser and say, hey, I want you to run this function, or I want you to now, after a particular time, set timeout, okay? Somehow you return me that so I can now run it. So this somehow is that internally uh, the browser say, let me now, once that time is over, put that function reference into some places, okay? And that place is a callback queue. So the callback queue here is now the place of the browser putting all of this callback reference. So we need to find a way of how can we now talk to the JavaScript world. And that's when the event loops kicks in. So the event loops will take a look at if the call stack is empty and say, hey, if the call stack is empty, yes, okay, now let me take a look at whatever thing we got in the callback queue, grab it and pass it to the callback or to the call stack. So now JavaScript can take control, evaluate that function, and then pop up from the call stack. And do that if we have now other functions in the callback here. And that's great because once you understand this model, it's like, okay, that's pretty simple. That's pretty straightforward. The problem is that what happens when you now depend on functions that will take more time to complete, or what happens when you started to depend on uh, previous tasks to complete, and that's when your code becomes wildly verbose. You have all of this callback inside of a callback inside of a callback and callbacks and callbacks and callbacks. That's what it calls is the pyramid of Zoom or the callback hell. So now the ECMAScript designers say, would it be better to find a way to resolve all of that callback in one single line of code? And if you need to actually nest it, okay, Let's go to do that in the next line, dot then. So here is when we started to look at the promise uh, approach. So in the context of using now fetch, which is after all, it returns you a promise, okay, as a way to talk to other services. Fetch function is do behind the scene is doing two things. It creates not only a promise object in JavaScript, which value is the value that initially is undefined, the status that initially is pending, as well as some collection or arrays that is unfulfilled and unrejected. So it's in there where you're going to, when you define your promise, dot then, and this is one of the things that I don't like about this dot then, because at the end of the day, it's quite confusing because it feels like when this promise is done, I want you to, this is what is going to happen. Uh, where here you're not saying this is not what's going to happen. You, in fact, are going to attach is a callback when the value gets updated. In this case, when the status is successful. So when the status is successful, now it's going to run, or when the value you get it, now you're going to run this the callbacks on this unfulfilled array. So for example, you got this and the end promises here, using the fetch API exactly. So now it's explaining how you can do that. Again, what you're doing here is just passing is a callback here. That's what you do. And then this is going to be attached to the promise object. So this promise object, what it's going to do is that it's like, okay, when this value change, okay, uh, which is the result of this another operation that fetch is doing, because fetch now here do two things. One, create a promise object in JavaScript world and then communicate to the web API, the network API layer on the browser or on the server. In our case, in our case, the browser, and going to pass all the relevant data that it needs to. So, for example, here we're going to pass is uh, well, the protocol, the domain, the methods, the format that we're going to get that data. It's a JSON, it's an XML. And doing that, okay, is now uh, how can we define, okay, or in this case, how now the fetch or this parquet function talk to the browser and say, you know what, once that so once you perform that request, okay, then once that request fly away and we get something, in this particular case, we get the result, all right? Okay, I want you to now update the value on the promise object, okay? And because we are passing is in when the fetch function communicates to the browser, it not only performs that task, but also holds a reference, holds a callback, holds a function reference to say, all right, now once we get that value, this is what we're going to do. The question is that how now JavaScript, or in this case, how now the browser uh, put this, where is going to store this as a way to, well, manage all of these async things that are happening, all of this remote code. It's stored that on the micro task queue. So this micro task queue, is something that'll be evaluated by the event loop. And there's some caveat here because first, the promise, the microtask queue has a higher priority than the callback, one. And second, the more if you continue adding microtasks to the microtask queue, yeah, the event loop will continuously grab on. Uh, First, it's gonna check if the call stack is empty, but the event loop will continuously grab each one of those elements from the microtask queue until that is empty. So you have to be careful here because if you for some reason define more or you enqueue more micro tasks, which is by relying on using continuous promise, uh, then you might end up having an endless loop in there, which of course it will never reach to the callback queue. So you will have some performance issues. So that's one of the caveats here of using now promises, or when you want to now add tasks or micro tasks to the micro task queue. So um, the specification called that job, okay? But for our case, is like that, and that's quite very, very interesting because now when we have the ability to describe what's going on there, okay, as it is. So what do you think will be what do you think will be what will be, do you think, what do you think would be the value of fetch prompt? That's a valid question. Here, it will return an object, which is one of the things that fetch functions do. What is the thing that fetch function does? Create an object here, and initially is pending with the pending state. There you get it. Network when attempting to fetch resource. You see, it returns you this object that contains the state and the reason for that. So that's right. And for some reason, it's like, no, it can't fetch that. That's quite interesting. That's quite interesting. That's quite interesting. But because we haven't, for example, here, it fails because uh, since we haven't attached a callback here, okay, since we haven't attached a on on rejected, since we haven't attached is a callback to on rejected array, uh, so we weren't able to handle that error state, so it returns us an object here. So if we run this again, but now with all of this, okay, read the declaration of fixed promise, that's right. hmm So that fails because now from core policy, content security policy, exactly, some course connected source. But this is now for the browser saying, "Hey, I'm terrifying of what you're doing, and I'm not gonna let you send. I'm not gonna let you do that." Here we're fetching is all of the property that we need to. As you can see, we're making a get request. Okay, it allows to do that, but from the console it says, "I'm terrified of what you're doing." Okay, so the page settings block the loading of a resource connect source to this because it violates the following directive. Connect source self. So it seems like it's not able to actually is uh, connect through one of these origins. So again, this is part of the uh, script injections and that kind of thing. So if we, for example, now make this request, let me copy this. If we make this request from another tab here, which now uh, we're making that request is from audience here, we should get now is the value for that. You know, the subtle difference was is that hey, you're making this request here under this origin, and then we don't want to do that. It's like the server replies like say, I'm scared of who you are, and I'm not gonna let you do that. But now because it comes from a different place, a different origin, you say okay, it's okay, fine, good. And here, as you can see, we got the state and the value, all right? And the state and the value. And because after all, this promise is an object, it holds a proto-reference that points to the prototype promise function constructor where you can have access to the property and methods from this promise object that is, well, then dot catch, as you can see here, dot then dot catch a constructor finally. Okay, where now that dot then it contains is interesting. So that dot then contain is a the prototype, or in this case the proto contains a reference to the function constructor object where you can have access now to the apply and bind and call uh, and other relevant methods from the functions prototype. That's one of the lovely things of looking at this. And because everything in JavaScript is an object, okay, that function prototype has also a reference to the object prototype, what you can have access to has property, is prototype of, to local string, value of, and that kind of thing. Until that proto at this point is null. Mm, 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 mm. Now this is from the prototype until that proto is null, as you can see, which indicates that this is it. This is the end. Uh, so this is now the nature of the prototype object-oriented programming on how you can access to property and methods through this prototype chain as a way to being memory efficient for sharing functionalities. That's something interesting, very powerful to know, especially if you're going to build these large applications. So this is it. Okay, this is it when it comes to promise. Okay, and even though you can change them using the dot then, and also when it comes to catch error, you can define using the dot then dot catch, which means that whenever of this, whenever if when doing this async operation, uh, something wrong happens, hey, I want you to run this callback here. I want you to run is the catch, the callback that I define on the uh, catch. That's That's great. That's great because now when it comes to actually defining multiple arrays of collect or multiple, um, yeah, when we define this now uh, to define multiple collections, to talk to multiple services, okay? So you define several promise to that as a way to say, let's say you want to ensure that a transaction actually is fulfilled. Let's say you want to send $10 to your mom, and your mom has in a different bank account as yours. So the idea here is to say, hey, I want you to now communicate to my own bank account as a way to notify that, hey, I'm gonna withdraw my $10, and another promise that I say, hey, I want you to now is deposit 10. Another promise, I'm gonna deposit that to the bank, to my bank's mom's account. Okay, so because this transaction must guarantee, so you need to guarantee that that transaction exists or happen properly. Uh, we have something called is the promise that all that allows you to do that. The problem with this is that with promise that all is if any one of them fail, it won't give us which one of them failed. Whereas with promise all settled, it say, hey, this is the entire promise collection, okay, and it's gonna tell you if one of them fail by returning is this project is this promise object with the value as it is, it is, come on, okay, with the value as you can see, this promise object like this, a state rejected. Okay, and then we can now look at the state and say, hey, this rejected. Okay, something wrong here. Give me the reason, which is a property here. That is one of the things that a lot of these fintech companies or um, yeah, a lot of these uh, fintech is actually are looking for is that how can I make to guarantee that this transaction actually happen as it is? We need to do that. All right. So, in any case, uh, you might wonder, it's like, okay, this is a good approach. If again, here we need to define is a little bit of line of code. It's also quite uh, descriptive, but wouldn't be a better way to actually, because after all, in the nature of JavaScript, is that it's going to evaluate one line after the another. Okay, so when we execute uh, this line, this async line, I want you to make sure that at the end of the day, the next line is when I get the value. Okay, or if I don't get that value, well, find a way to how can I catch error from that. And that's where it comes here with the async and await. And first things first, we need to take a look at a couple concepts as a way to understand how that works behind the scenes. So that's why we have here iterators. But the thing here is that with promise, callbacks, micro task queue, web APIs, and the event loops is what allow us to defer a task or a work until completion, and then in the meantime continue evaluating line by line our code. So that's what now allows to build powerful modern web applications in JavaScript that doesn't block. That's good. That's very compelling here. So because as we write our application, okay, And we also need to understand these two particular concepts, the iterators and generators. A way to understand is now uh, async and await works behind the scenes. And with iterators, or usually when you write programs, you define it as a state, which is the live data, as we usually call them, which contain instance property and methods. Okay, but usually we tend to work is not with one single object, instead with a collection of them, with a map, set, or array. Uh, so even accessing to an object is even a task in itself, because now you have is to indicate how you want to actually get that data. Okay, and at the end of the day, what we want is to get the data and then do something about it, apply some transformation. So what would be better way that any time when we run a function, okay, uh, we get the data on the first position. If we're talking about in a collection of data in an array, hey, anytime I run this function, I want to get the data from the first position. I run this function again from the second position. Run this function again, the third position, so on and so forth. So now, how can we actually create that in JavaScript? Especially, how now can we keep track is all of this position and store and remember somehow where at which position we are in the collection. So for that, first we look at how can we now using the for loops and how imperative is that. Actually, we have much more fine control about what we are doing, how we are doing. But remember that after all, at the end of the day, we want is to get the data, apply some transformation, and move on. Okay. And here with iterators, particularly when looking at the for loops, okay, uh, an alternative to make this happen is that when you write a function and you want to iterate through each one of those elements, okay, for example, here, and then you return that function, here what you're doing is to effectively creating a closure, okay, because at the end of the day, that's pretty much what we want to do. Right? We want us to create a closure. We want us to now look at ways to persist the state of our data as a way to keep track of which collection we are and which position we are in this collection, uh, and from there get the data. So that's exactly what we're doing here with this particular function, right? We first created this function, and inside of that, a particular functionality where it will now keep track at which element we are on the array, and then return that array. And after that, we return is that function. So once we pass this array for that, and anytime we run the inner function here, we will have now this way of getting this flows of data anytime we need it. And that's pretty interesting because once you now create a function that returns a function, behind the scenes it creates a closure or a close over variable environment as a way to persist the state of our outer lexical scope. Why this is important? Because with this bonus feature of JavaScript, this beautiful design of JavaScript, is that now we can have persist states, okay, where inside of that we can not only keep track of which element we are in the current position. We also can use, for example, if you're developing a game, you say, I want you to now run this when the player wins, okay, once, okay, or you can now is define things like memorize as a way to say, hey, let's let's gonna do something not that fancy, but then you can imagine then more complex operations. For example, what is 9 times 9? 81, right? So I would like to find a way that any time that somebody else asks me that, I don't even have to think about it or to compute about it. Somehow I store that result and then I give it to you. And that's exactly what closures also allow with this memorize function. And that's something beautiful. And again, this is also part of this uh, nature of high order functions and that kind of thing. So yeah, that's part of the required knowledge that we need to as a way to understand if the uh, async and await nature. Because at the end of the day, with iterators, which is this functions that will give us is the next element, all right? In with that approach, now we don't need to know how to access the data, okay? We in fact now how so now we don't need to know is how can we access to the data, okay? Because it's that. So we don't know any. So right now we don't know any longer to know how can we access to the data. In fact, we now can think of what we do with the data completely. So we go from how to access to the data and then do something about it, and then we decouple that by saying, well, I don't know how you get the data. Do that in the most efficient way possible for me uh, because all that I care is now what I have to do with the data. And that's something that a lot of people here, especially senior developers, actually knows very, very well. So finally, let's talk about is generators. Yep, let's talk about generators, my friend. Generators. Let's get into it. Let's get into it. Let's get into it. So once we start thinking of our data as a flow where we can pick an element one by one, we can rethink how we produce those flows. Mhm. How can we get elements one by one? Okay. Now can we reproduce those flows? Yes, we're building iterators are actually objects with a next method. That when we call return the next element from the stream slash flow, so let's restructure slightly. Okay. They have an object. Yielding. By yielding. What is yield? Yielding. Soft substance of, or quality that are yield can be bent. Yield. Oh, okay. Yield. How? Yield in Spanish? Yield in Spanish? Oh, interesting. Hmm. Oh, Jill. Oh, okay, Jill. Oh my God. Okay, Jill. Interesting. Harvest, production, output, yield. Interesting. Okay, yield. Bone yield. What they call bone yield. Oh my God. Okay. Okay, bones raised yield. Okay. Okay. Okay, as a verb. As a verb, yield as a noun, an amount of something positive, such as food or profit that is produced and supplied. Crops yield has risen steadily. But again, this is very British. This is British, bro. Crops yield, cross outputs, cross performance, crops production have has risen steadily. That's quite interesting. Oh my God. Okay, yield production. Okay, let's produce our supply exactly. So crops yield how crops production have risen steadily. Yields on gas or productions of gas and electricity shares are consistently higher. Productions, okay, anything that is related to production, to produce. Interest, that's yielding, that is, oh my God, that is yielding. Okay, okay, okay. Mm-hmm. 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 Okay. Okay. All right. Okay. Okay. That is dealing. Mm-hmm. That is dealing. Oh my God. Oh my. Okay. So right now what I'm doing is just taking notes out of this. Okay. So we call this the method on. So the next element is an object, not a. Mhm. Okay, we don't call the next thing. Instead, we call is the method on it. Okay, because instead of this is an object that is wrap a function here. Hmm. Okay, so first line. So we're defining is a create flow function. That's right. Uh, so next line is return next element. Okay, we're gonna define is a const return next element, and we're going to assign the value from whatever create flow is doing that we don't know right now what it is. That we don't know what is the what that will be is there, but right now it'll be the return value of create flow. Return next exactly. We're declaring a constant call return next element, which is undefined right now, which will lead out the return value from create flow. Exactly, because this is so here we're going to define a const return next element that where we don't know what it is right now, but it'll be the return value from create flow. And I think this is something important, especially when doing this kind of thing, that by describing here. Okay, but the first line is we are defining is a function called create flow in our variable environment. Right now, global variable environment. Next line is we're defining is a const return next element that we don't know what is the value of this, but we don't know what is the value of this, but it'll be whatever create flow returns it. Next element will be the output of the return value from create flow. Exactly. We hope we get an object with a function next into the return flow. Mm-hmm. 4, 5, and so on. The defining the parameter array, which argument is called an array of 4, 5, and 6. Mhm. Mhm. As an object. Exactly. A method of an object. We're gonna define as a function as a method of an object. Is inner, okay, where this object is next here. Hmm. Because we are returning is this as a function. Hmm. Oh my God. Okay, anytime you are returning a function from a, oh, okay, it can have access to the other scope. It can have access to the outer lexical scope, to the outer variable environment. Okay, okay. We are defining is this as an object where now this property called next, okay, it'll be function scope. Um, exactly. Here we are justifying is an object. The inner function because the word returning is the inner object. That's why interesting here. It's because we're returning is a function. Of course, of course, it's not here. It's here. It's because now this property, even though if you define an object function, you are now the okay. That's quite interesting. Even though that you have nested properties, even though you have objects, if one of them, if that's quite fun. Okay, so far we have looked at we create a closure is with by returning a function. But if you are returning is an object, and each one of in any one of those objects has a function inside of that, they can have access to the lexical to the other lexical scope. That makes a ton of sense. Hmm. Exactly. Object will return next element method. Life stage data attached to function definition. Here's this. It goes element one with a clear element here. Exactly, with a clear element here, and their value will be whatever is the return next object. Yeah, whatever return next, uh, whatever return next element dot next method is on memory, on the global memory here. And then do we have is the next method here, an execution context here. We are defining, um, okay, we got a live data from the array. Well, we're supposed to have a live data there. Mm, that's quite interesting because, okay, declare element here. hmm in the backpack. No, that's not in the local execution context. No, raise value. Exactly. What it's doing is not evaluating the where this object function is going to run that. But now here, initially when you run this function, you create a new branch execution context. You define the element, const, and then you assign that uh, whatever you have in the array, the position I. In this case, do we find that in the local memory? No. Where it is? Oh, it's allegedly supposed to be in the backpack because now we are assigning this because now we have this function method here that we are assigning here. The question is that, but closure doesn't work like that. Well, according to my rules, element one. Mm-hmm. Mm-hmm. Exactly. Mm-hmm. So because we iterated, we can. So we iterated, we don't care. Okay. So we iterated, we don't care about how to access the data. We're just going to get that. But we with iterators, when we generate this, we say, hey, I want you to now output this. Okay. So when you call me, I want you to do this. When you call me again, I want you to do this. So when you call me, I want you to now process this promise. So when you call me, I want you to process uh, this. Hmm. When you call me, I want you to now process it. So meaning is that pass down to the callback or pass down to some sort of callback. And that kind of thing. Once we start thinking of our data as a flow, we can see of an element one by one. We can rethinking how produce those flows. Because exactly when we start to thinking how can we get one element out of data, one element one by one, okay? When you hit this function, you get this first element. When you hit the function again, you get the next element, you get the next element, you get the next element, and you don't care about how accessing through your data is happening. That's something is an task in itself. That's what you have, for example, binary search, or yeah, that's what you have is this searching algorithm. So searching algorithm. Oh my God. Searching algorithm like uh, breath this first. Search algorithm is an task in itself. Uh, is an task in itself. Search algorithm, acting like binary or half interval search. So binary search is one of them. It's like, hey, I had this collection, so this particular approach is like split this is to ask here. Is to first split this up this collection and say, hey, do we have this number here in this set? No? What about this set? Yes. Okay, let's go to discard that. And now let's go to split that and do the same. You know, searching isn't a task in itself. So accessing through your data is not task in it itself. So for example, if you take a look now at search search searching algorithm, okay, search algorithm, linear search or binary search and code complexity, you know, exactly you have or linear where you say, hey, let me not find this element until I find it. So if this collection is massive, Jesus, Jesus. But again, another approach is that let me split this collection, and then if one of these number is inside of one of these places, you're gonna discard the other, which make it much more effective and efficient. hmm And the time complexity of this binary search is log n. Um, and there you go. No. I'm not sure. I think it is this bigger cheat sheet, and there you go. Exactly. Array sorting. This is common structure as a way to access data. This is that data structure, common data structure operation. Exactly. And then you have is now sorting. Uh, Sorting, but not searching. That's interesting. Yeah, it's an attack in itself. Completely, man. It's an attack in itself. Exactly. So we're defining here the return next elements, which value, which is undefined, which value is whatever create flow is returning, which we don't know. Mm-hmm. No? Okay. Or we hope an object. Object. Mm-hmm. Mm-hmm. Exactly. It's an object. Exactly. We are now is declaring is element one. And this time we are now accessing the return next element object that somehow it has this function called next that we don't know what is the value that we suppose that the value uh, should be is 4. Wait a moment. You are calling a function that was previously run? I mean, you can you do that? So where the fuck are you storing that? Oh, the closure. Oh, oh. Yeah. Because at the end of the day, it's like JavaScript is evaluating line after line of code. So any other functions that was previously executed, they're gone. They fulfill their existence. They're like Mises. I don't know if you already any one of you saw the I don't know if you any one of you saw is Rick and Morty, Mises, Mises, right? Where once you hit a button, you tell them what to do, any command, anything, I want to be rich. All right, I'm gonna help you to be rich. Ah. And when they fulfill that mission, they're gone. you know, they are gone. And that's a very interesting. Yeah, they're a very interesting character, right? Exactly. Everybody in English, man. Yeah, on English, much better. Can we set this on Spanish here? Rick and Morty. Da, 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 da. Mm. Night mode. Exactly. Much better. Okay. So yeah, yeah, we got it. So they expire and vanish into the air. The motivation to help others come from the fact that the existence is painful. To mystics, and the only way to be removed from existence is to complete the task what they call to perform. Physical violence or damage cannot eliminate them. With multiple mystics in this episode sustaining several head trauma, to the point of having a dark section of the head cave in their eye pooping out of the socket, or bodily mutilation. An earnest retention of what is inside of a mystic looks. Volume 6. Serve a human purpose. They're quite interesting. Again, this quite is right off the topic of this. But the thing is that because we're talking about generators, you know, since we're talking about iterators and generators, since we're talking about generators and generators allow us is to run previous functions that was previously executed. But at the end of the day, those functions were not previously executed. After all, there was just a object that hosts a function there, which which that makes sense. That makes sense. Okay, let's going to keep moving here. Exactly. Suspending the execution context. Exactly. It's suspending the execution context. 2 element 1. But what does it mean with this suspending execution? Suspending from holding execution context. So here the next element would be is the element 2, return next element dot next. Mm. 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 an object with the next function. We're going to define class element one and assign to the return next element object that we're calling the next. Okay, okay. So we're going to define is the next. So we're going the next line is defining an element one as const and assigning whatever the next function from the return next element object uh, is provided. Right now we don't know what it is, but we'll figure it out. But we hopefully figure it out with the create flow. We define a const node with value 10. Create a new con new num. Oh, because it's analyzing line. Yeah, oh, it's analyzing line. Exactly. We're very chance is 10. Mm-hmm. It's just in the state and the thread of execution. Mm-hmm. That's the function. That's the execution context. It's the thread of execution and the state, and the memory. Where I, which line of that thread of, which line of that thread of execution, which line of code I am in, what is my state? Where's my local, or my variable environment? Hmm. So we have is the backpack and the position of the hmm is the state, the position in the callback, the position in the function execution, the threat of the execution into the create flow again. Well, God damn it, pretty much like a Mafusa. Mm-hmm. Because okay, at the end of the evaluation, in the local execution context, it's like we pause the execution context, but this is part of the design of that. And then evaluate the okay, and then evaluate that. This is iterative. This is the one that's not running. Is that exactly how all the information here? And let me go to continue that. Exactly. What, mm-hmm. Exactly. Now, what is the end goal of this? Okay. Yeah, go inspect, bro. It's like go inspect, bro. Mm-hmm. Generators. Generators in ECMAScript. No, wait, what? Um, ECMA, exactly, ECMAScript. Here, go to generators. Generators. This is a special type of generator of class term. Generator function control abstraction objects. Hmm. Generator function. So property of the generator function prototype object. The generator function prototype object say, hey, is generator function dot prototype? See figure 6. Is an ordinary object. Is not a function object. And does not have the ECMAScript code internal slot or any other internal slot listed in the table 30, which is this. Okay. Or table 88, generator 10. Okay. And does not have an iterator slot or any internal slot listed in the table 30 or in the table 88. Generator state. But this is generator function object. But this is generator function object. Okay, but this is generator function object. I construct that have is okay, generator function objects. No, it's okay. Constructor prototype, generator function prototype is here, generator function instance. But I want to take a look now. It's not the generator function, it's the generator object, bro. Exactly. So a generator is created by calling a generator function and conform. Yeah, a generator is created by calling a generator function and conforms to both the iterator, this function that allows to get access, okay, to the iterator and the iterable interface, iteration to the iterator and iterable interface. Hey, this is an iterator. Is this function allow you to run inside of this iterable, this collection of values? Yes? Alright. Generator instance directly inherit property from the initial value of the prototype. Okay. Property of the generator function. Generator instance directly inherit property from the initial value of the prototype underscore proto underscore the dunder property of the generator function that create the instance. Generator instance indirectly inherit property from the generator prototype. And the generator prototype object is a generator function prototype. Okay, is an ordinary object. Is not a generator instance and does not have the generator state. Internal slot has a prototype internal slot whose value is iterator prototype. That's quite interesting. Mm-hmm. The iterator prototype object. Mm-hmm. Iterator prototype has a property that are indirectly inherited by all generator instances. It has a property has that are indirectly inherited by all generator instances. Generator instance. The generator prototype. So it has now this object, which is the generator prototype object, and then you have the generator prototype constructor, the next, return, throw, and to string tag. Okay. So you have the next, where return the generator resume. So generator resume is the abstract operation generator resume takes arguments generator an English script language value, which is any data type, okay, and an English script language value or empty, and generator brand, okay, a string or empty, and returns either a normal completion containing an English script language value or a throw completion, and they perform the following step when called. Let state be the generator validate. So generator validate, the abstract operation generator validate takes an argument generator, English script value, and a generator brand string of empty and returns either a normal completion containing one of the suspend star, suspend yield, or complete, or throw a completion. It performs the following step when called. Require internal slot. The abstract operation require internal slot takes argument O and in any value, an internal slot name, and returns either normal completion containing unused or throw completion. It throw an exception unless O is an object and has a given internal slot. It performs the following step when called. If O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused. Okay, but it says it throw an exception unless O is an object and has a given internal slot. If O is not an object, throw a type error. If O does not have an internal slot, throw a type error. Otherwise, return unused. So this is an abstract operation. When they say abstract operations are methods here. Require internal slot that it takes an argument. Okay, it throws an exception unless O is an object. Exactly. O is an object and has a given internal slot. So this will return, okay, we throw an exception unless O is an object and has a given return in use. So this requires internal slot that is generator validate. What in the fuck? That is generator, okay, generator validate. Generator validate. It performs require internal slot. That is, this require internal slot return is unused. Perform unused with generator state. Perform require internal slot of generator state and generator brand. Okay, it will return if the generator, the object, and the generator state internal slot. It throw an exception unless op is an object and has an internal slot. So it return is okay. Perform the generator state, the generator brand. If generator brand is not generator brand, throws type error. Assert the generator also have a generator context internal slot. Let state be generator state. If state is executing, throw a type error exception. Return the state. So all of this is just to return is the state. Where this state will contain is the generator state. Will contain is the context for that. If a state is complete, return create either result object. Assert state either suspend star or suspend yield. Let gain context be generator context. Let method context be running execution context. Suspend method context. That's quite interesting. Okay. Iterators and generators bring the concept of iteration directly into the core language and provide a mechanism for customizing the behavior of for-of loops. particularly here. For details, see this iterator protocols, the iterable protocol, and the iterator protocol. The async iterator and the async iterator and async iterable protocols. So iteration protocols are new builds or syntax but protocols. These protocols can be implemented to any object by following some conventions. There are two protocols, the iterable protocols and the iterator protocols. So what is the end goal of this? The iterator protocol, the iterable and iterator, the async iterator and async iterable interaction between the language and iterator protocols. Building API accepting iterables. Okay, god damn. And if I take a look now at, okay, and if we take a look now at the generators here, while custom iterators are useful tools uh, to have access to all of these elements of data, uh, we don't have us to write how we're going to access the data, which is a task in itself. Okay, their creation requires careful programming due to the need to explicitly maintain the internal state with iterators. Exactly. Generator functions provide a powerful alternative. Mhm. They allow you to define an iterable algorithm, okay, by writing a single function whose execution is not continuous. Okay, the execution is not continuous, but even though they allow you to define a specific iterator logic. Generator function and written using the function syntax. When called, generator functions do not initially execute their code. Instead, they run a special type of iterator called a generator. So when a value is consumed by calling the generator.next method, the generator functions execute until it encounters the yield keyword. The generator function execute okay, the generator function will execute until it finds the yield keyword. And what is doing when that happens? So the function can be called as many times as desired and return a new generator each time. Each generator may only be iterated once. Mhm. Each generator may only, or each function may only be iterated once. We can now adapt the example from above. The behavior of this code is identical, but the implementation is much easier to write and read. So we have make iterator as it is, and here we define as an object, okay, where this object will contain is a function here, mhm, which means that we're defining some logic to get the next element. Oh, okay, this is something great, especially for linked lists. When you don't know linked list graph, or when you don't know what is the, oh, okay, when you don't know what is the end of this collection. Mhm. When you don't know what is the end of this collection. Mhm. when you don't know what is the end of this collection. Range iterator, value iteration count and down true. Exactly, because it's this. Using the iterator then looks like this. Make range iterator like so. Okay, exactly. Because most of the time we actually, instead of handling with the data and the functionality, one one of them we usually deal is with uh, large data sets, collection of data sets, several states of that. And because of that, so iterators, one particular use case is when you want to look up through collections of elements where you don't know how long they are. Useful, especially. Mhm. Okay, okay. This is something useful when you want to, for example, is ah, ah. These iterators is something useful when you want, for example, to define onboarding process. Okay, you want to hold the state of this onboarding process as well as all of this data, and that's something beautiful and powerful. Okay. Mm-hmm. Mm-hmm. That's it. Mm-hmm. 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 But again, we have to. One of the things with this iterator is because it's using closure behind the scenes. You have to be careful about the inner state. Okay. Mm-hmm. Mm-hmm. So when a value is consumed by calling the next, so generator function provide powerful alternatives. They allow you to define an iterative algorithm by running a single function whose execution is not continuous. So if you want to now define an iterative algorithm, hey, this is one of the things, okay, for this particular use case. If you want to define is uh, an iterative algorithm, so they allow you to define an iterative algorithm. Okay, hey, I want you to go this, and then another one element, and then another one. An iterative algorithm, one after the another. So let's go through each one of them. An iterative algorithm by writing a single function whose execution is not continuous. Okay, by writing a single function whose execution is not continuous is when we run this. Generator functions are written using the function syntax. So when called, generator functions does not initialize, execute their context. Instead, they return a special type of iterator called generator. When a value is consumed by calling the generator, mhm, and when a value is consumed by calling the generator next methods, the generator function executes until it encounters the yield keyword. Exactly. So when a value is consumed by calling the generator next method, the generator function executes until it encounters the yield keyword. It's like, hey, produce outcomes, yield, provide. Mhm. The function can be called as many times as desired and returns a new generator each time. Each generator may only be iterated once. We can now adopt the example from above, and the behavior of this code is identical, but the implementation is much easier. Uh-huh. And after all, you are now creating effectively is a closure here. Here you are creating is a closure here. But now with generators, it's not only creating is a closure behind the scene, which now contains the state of your function at that current moment. Mhm. So here it will go through this. So once you do is this, because after all what we're doing here, uh, and I want to know what is the main use case of this. It's like what in the F is this? Okay, is that n infinity. So anytime we call the make iterator here, dot this is an object dot next is not a function here. I need to run it. I need to assign something here. Let's say make iterator. So this is generator here. Now generator by itself is supposed to have a method called next that when it evaluates the next method, which is make range iteration, it's going to evaluate the function you define here as an iterator. It say, hey, this is the initial value that I get, step one. Okay, iteration count is 0. And here I'm going to iterate until, okay, I'm going to iterate until, okay, until that position is less than n, which is infinity. Okay, so he's going to do that forever. And entering this loop, increment the iteration count, and then return this yield for that. Initially is 0. And again, it returns the value 0 and don't false. Value 1 and false down. And if we want to know what this generator is, generator is not a function, it's an object. What you can now run is the return. What? Value is undefined. But you can call the next. It's like somehow it loses state from that. Because when I call generator, Okay. Once I call generator, it's like somehow lost the state. Okay. Okay. No, no problem. No problem. No, it's okay. 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 Ooh, you lost that. My God. Okay. No problem. Mm-hmm. And we have this followed by this. Mm-hmm. Let me now refresh this, reload this, and here when we say generator dot next, okay, so when he evaluates that yield statement, so it will evaluate that function until the yield statement. And in this case, we're going to return, or we're going to pause the execution so it yield that value. In this case, it's 0, in this case, it's 2. And the funny thing is that it also returns an object called return. Hmm. And now okay. Oh, so oh my God. Okay. So this is indicating, hey, we're already done evaluating this. Oh my God. What the F is this? Make iterator like this. An object is iterable and is defining its behavior such as what value are looped over the for loops construct. Some built-in types such as array or map have default iteration behavior, while others such as object do not. In order to be iterable, an object must implement the the add iterator method. This means that the object or one of the objects is or is prototype change must have a property within the symbol.iterator key. Okay, the symbol.iterator key is a way to identify this. It may be possible to iterate over iterables more than once, or only once. It is up to the programmer to know which is in the case. Iterable which can iterate only once, such as generator, customarily return this from their iterator method, whereas iterable which can be iterated many times must return a new iterator on each occasion. User-defined iterables, built-in iterables. Advanced generators. Generators compute their yield values on demand, which allow them to efficiently represent sequences that are expensive to compute, or even infinite sequence. Exactly, as demonstrated above. Generators compute the yield value on demand, which allows them to efficiently represent sequences that are expensive to compute, or even infinite sequence. The next method also accepts a value which can be used to modify the internal state of the generator. A value passed to the next will be received by yield. Mhm. those values as a way to generate okay output in this okay as a way to generate is chunks of data as a way okay based on an algorithm on an so you have now iterated if you want to generate regular output let's say patterns at infinite this might help you to do this or if you want to efficiently represent sequences that are expensive to compute. Represent sequences that are expensive to compute. Very important here. Represent features that are expensive to compute. Okay, or even infinite sequence. Expensive computation of sequence of data. You can force a generator to throw in a section by calling it a throw. Mm-hmm. Holy moly. And then you got his JavaScript model. Mm-hmm. Jesus, that's right. Jesus, that's right. Ah, the generator context, where it an execution context. Oh my God, it's an execution context. You got a generator state that it contains the suspend start, suspend yield, executing, or completed. The generator context and the generator brand, a string or entry. A brand used to distinguish different kinds of generators. Mhm. So, so you cannot see what I'm actually looking at is this one. Is a generator object, not only the generator prototype, okay, but it's also the properties of the generator instance, which will live inside of that. Generator instances are initially created with the internal slot described in table 81. Mm-hmm. Generator state, generator context, and execution context. The execution context that is used when executing the code for this generator. It has an execution context here. It holds the execution context. And an execution context is a line where you are, okay? The lexical environment, the data, the variable, the private method. Additional state component for generator execution context. Generator. The generator has this execution context, has that this execution context is evaluated. In most situations, only the running execution context, the top of the execution context stack, the call stack, is directly manipulated by algorithm within the specification. Hence, when the terms lexical environments and variable environments are used without qualification, they are in reference to those components of the running execution context. Hence, when the terms lexical environments and variable environments are used without qualification, they are in reference of those components of the running execution context. And when they mean the running execution context here is at exactly at any point in time, an execution context is a specification device that used to track the runtime evaluation at which line of code where I'm currently at. Okay, at which line of code I'm currently at. And this is execution context. And the other, what is the state? What is the variable that I have? This is at most one execution context per agent that is actually executing code. This is not an agent running execution context. All reference of the running execution context in this specification denote the running execution context of the surrounding agent. So an execution context contains whatever implementation specific state is necessary to track the execution progress of its associated code. Each execution context has at least a state component. Okay, each execution context has at least a state component listed in the table 25. Code evaluation state. Any state needed to perform, suspend, or resume evaluation of the code with its execution. The state of this function, if this execution context is evaluating the code of a function object, uh, then the value of this component is a function object. If the context evaluating the code or script or model, the value is null. The realm. The realm record from which associated code access ECMAScript resource and the script or model. It also is an execution context. The model record, like this, the model record fields rel environment, namespace, host defined, script or model. Then execution. Code execution context has additional state listed here: lexical environment, variable environment, and private environment. So those execution context, which is the execution context, meaning is that this is the current line at which I am this is the current line which I am in the code that has an associated, okay, has additional state component like the lexical environment. It's the memory here, as well as the variable environment or the private environment. hmm Holy moly. And when you talk the execution environment, the execution context here, you refer is at which line of code you are currently at in runtime evaluation. Is used to track the runtime evaluation code. Holy moly. The generator context is what actually holds is a reference of at which line of code I'm currently running. God damn. As well as the state, which is generator state undefined, suspend start, suspend yield, executing and completed, and the brand. A brand used to distinguish different kind of generators. The generator brand or generator declared by ECMAScript source text is always empty. Yeah, damn. Exactly. Exactly. You can keep so with this model, you can now is have an essentially is a loop of network connections. Exactly. Mm-hmm. Exactly. Only when the tag is complete. Exactly. Because the point here is to say, uh, would it be better if we actually now throw a task? eh, Would it be better to now have a? Would it be better to have a throw a task and once that is complete, we get that value, something like that. All right. Okay. Holy moly. uh, well, that'll be all for this video. Take care.